Problem 35, we're asked to find the minimum distance between A and B, which are two points on equilateral triangles given to us. So we're looking for that distance that I have marked in blue. Now, best way to approach this is to break that blue piece down into two separate pieces. We can find this, which we're going to call the height, we can call it H1 of the larger equilateral triangle, and then we can find what I'm going to have in green as H2, which will be the height of the smaller triangle. So if we go back to the problem, it looks like they gave us the area of each triangle. So if we take a look at the area of our larger triangle, it's given to us as 300 square centimeters. Since we're working with areas of triangles, we're going to be using the formula area equals 1/2 base times our height. So if we apply that to our large triangle, our area is 300, 1/2. Now our base is going to be this distance right here. Okay, now I'm going to clean this up just a little bit so we can see what was given to us. But it looks like just this part here is x. It's the length of x. Then we have these two smaller sections here and here that are y. So we're going to add 2y, and that would be the total length of that base. Now our height, we already said we're going to call h1. So if I find this h1 height, I'm just going to isolate that part of my equation. So what I'm going to do is I'm going to multiply both sides by 2. Like that. The 1/2 and the 2 simplify out, so I'm just left with x plus 2y times h1. And then on the other side we have 2 times 300, which is 600. Then lastly, I'm just going to divide by x plus 2y. So our first height is 600 over x plus 2y. Now we're going to repeat that same exact process, but we're going to do it with our smaller triangle. Okay, so if we go back to our the question, our smaller triangle is 200 square centimeters for our area. So it's going to be 200 equals 1/2. Now my base for the smaller triangle is just x. And then our height is h2. So to solve for h2, we're going to multiply both sides by 2. And just like before, the 1/2 and the 2 would simplify out. You have x times h2, and we have 400. Now dividing both sides by x, we find out what h2 is, and it's going to be 400 over x. So if we're going to find this distance that we had originally marked in blue, the minimum distance between A and B, we're going to take our h1, and our h2, and we're going to add them together. So we're left with this expression. We're going to get a common denominator. In this case, our common denominator is going to be x times x plus 2y. So in our first fraction, we're going to take 600 and we're going to have to multiply that by an x. Our second fraction, we originally had 400 and we're going to have to multiply that by an x plus 2y. So when we start to combine these, we still have a common denominator of x times x plus 2y. 600x is what we're left with in the first fraction, and after we distribute here, we have 400x plus 800y, and then we're just going to combine these two like terms in our numerator. That would give us 1000x plus 800y over x times x plus 2y. And that would be our minimum distance between points A and B.